I am sure by now most of you guys are tired of factoring. So I thought maybe a fun little math joke might help you or irritate you. Either way, we're coming towards the end of our factoring unit. This comic is XKCD, and it's by a guy that really loves statistics and math. So in this joke, this guy is sitting there and he's factoring time. So 253 is 11 times 23, and 11 and 23 are prime numbers. He's bored, so he kind of just started doing mental math in his head. And the guy in front of him changes the clock really fast, and 1453 is a much higher number to think of two numbers that multiply to it that are prime. And I kind of thought of you guys when I saw this, because I know a lot of you have to pick a really big number and think of two numbers that multiply to it but also add up to it. So I know that can be overwhelming and frustrating. So I understand that challenge. And with that said, we are coming to our very last learning target in this unit of factoring. So we've already learned how to factor out a GCF. That was the first learning target, right? We've learned how to factor GCF. We've learned how to factor a difference of perfect squares. And we've learned how to factor trinomials in several ways, okay? We've also learned how to recognize what method we need to use depending on the type of polynomial we have. So now we're going to move on to something that looks a little bit different, okay? We're going to look at something called a four-term polynomial that can be factored using a process called grouping. So four-term polynomial, remember a polynomial is any type of polynomial that has four terms or more. Okay, a term is those things separated by plus or minus signs, right? So if I look at this example right here, okay, this has 1, 2, 3, 4 terms, so it's definitely a four-term polynomial. We can factor this using a process called grouping. Now, when I first look at this, remember that rule of find the GCF first? That still stands. But what you're going to end up seeing with these types of problems is that there won't be a GCF. So when I look at x to the third, 7x squared, 2x, and 14, well, none of the numbers have a GCF, right? 1, 7, 2, and 14 have nothing in common. And it looks like they might each have an x in them, but then 14 is missing an x. So this problem looks like something you might write prime next to. If this were in the last learning target, you would put prime underneath this polynomial. But now I want to teach you a kind of a cool way that we can factor this, okay? Remember, factoring means that we take an addition problem, right? All of these are addition, and we turn it into a multiplication problem, like this, okay? Where if we use the x method and multiply, we get this addition problem. So we call this grouping, and here's how it works, okay? I've given you guys these nice steps to help you, because it's kind of a weird process. Step number 1, group the first two terms together, and then also group the last two terms together. Here's what I mean by this. By group, I mean make a set of parentheses. That's what grouping is. So I'm going to group the first two together. There, I've grouped them. I've drawn parentheses. Now I'm going to group the second two. Okay, I like to leave the plus sign not in parentheses. That's going to come up later. So I don't group the plus sign. I leave it in the middle. Okay, that's my first step. Not so bad so far. Now I'm going to factor out a GCF from each of these. So I've got this guy right here. I want to find the GCF of that. So I'm going to find my GCF. And what's the GCF of x cubed and 7x squared? It's x squared, right? That's my GCF. And then you write what's left over like always. I've got x left over and plus 7 left over. All right. Now I want to factor out this guy in here. I want to find the GCF of this. So I'm going to take this and I'm going to factor out the GCF. 2x and 14 have a GCF of positive 2. This is where this plus sign is important, right? So I'm going to put a plus 2 here, and then what I have left over is x and a 7. Okay? That's your second step. Okay, factor out the GCF from each set of parentheses, and you're going to get something that looks like this. You're going to have a term followed by parentheses plus a term followed by parentheses. Okay, now, here's what you should see when you do this correctly. You should notice that this and this are the same. Okay, that's supposed to happen. That's totally normal. So if these two things are the same, what we're going to do is we're going to pull it out. So I'm going to take this x plus 7, and I'm going to pull it out right here. Boom, x plus 7. Then I'm going to take these guys that are left over, the 2 and the x squared, and I'm going to put them x squared plus 2 here. Okay? This is called factoring by grouping. Notice I have taken a math phrase, a polynomial, and that was addition, and now I've turned it into a set of binomials that are multiplication. Now, if you don't believe me that this is actually true, we should assume in a perfect world that this answer right here and this right here are identical, right? That's how factoring works. You're just kind of reversing the process. So what I'm going to do is I'm going to create an area model, and you don't have to do this if you don't want to. This is just me proving to you that this method is real. I'm going to make an area model. I'm going to put the x squared plus 2 here, and I put the x plus 7 over here. Let's multiply this out. I get x to the third, 2x, 7x squared, and 14. And I can't combine any like terms. There aren't any, so I'm going to write this out like this. Do you notice that this thing right here is the same as this up here? If I erase this stuff, see how it's still x cubed plus 7x squared plus 2x plus 14? So this method does work, okay? You're going to get more into the reason why this works in Algebra 2, but for now, I'm just wanting you to understand that there are things in common that we can factor out, and there are ways that we can group certain terms together, okay? Let's take a look at a couple more examples. So here are two more. I'm going to try one, and then you're going to try one on your own. Okay, so the next one, I'm going to start with step 1. Step 1 says to group the first term. Oops, I've still got that weird pen. Let's do this one. I'm going to group the first terms together, and I'm going to group the last two terms together. Then I'm going to find my GCF. So the GCF of x cubed and 4x squared is x squared. I've got x left over here and a 4 left over here. Then I'm going to factor the 8x plus 32. Well, they each have an 8 in common. And then I'm left with x plus 4. Again, notice how the two things that you have factored out and what's left over are the same. So you're going to write that as one binomial, and then you're going to look at the terms in front and write that as a second binomial. And that's it. That's factoring by grouping. Okay? Now, you only want to try this if you've got 4 terms and they don't have a GCF, okay? This is the only time that that's even something you want to attempt, all right? Go ahead and pause and see if you can try this next problem on your own. All right, you should have gotten a squared plus 9 times a plus 2, okay? And if you didn't get that, please come talk to me. We will figure it out together. Now, factoring by grouping can be a little bit trickier when we don't have all positive numbers. Like the last couple examples we've done, all the terms are positive. It gets a little weird when we have some terms that are negative, so we need to be careful about that. So let's take a look at this first example. So the first example, same thing, we're gonna group the first and the last terms. My first two terms are okay, they're just together. Remember how I mentioned that part about not grouping in that negative sign? In this case, what we're going to do, because this is negative, we're going to group the negative in, and then we're going to write a plus between them. Okay, you don't have to do this. This is just one way I think about it. Because what you're going to see is when you get the GCF out of this is w squared, w plus 5. That's pretty normal. But when you pull this out, because both of these numbers are negative, they share that negative, you can consider that negative as a common factor, and you can pull that negative out as well. So when I pull that out, the 8 and 40, they both have a negative, so really they both have a negative 8. And notice now I have a minus 8 right here. And what's left over now is w plus 5. And one way you can check to see if that is correct, just draw your little distribution arrows and see if it works. Negative 8 times w is negative 8w. Negative 8 times 5 is negative 40, so you know you've done your signs correctly. That is a check I recommend doing because this is very strange with the signs. Once you've done that, though, now the next step is easy, right? Now you're just going to take your these guys, which should be the same, put it in one binomial, and then the w squared minus 8 as your first. Okay? All right, let's try the next one. First step, we're going to group. So I've got the p to the fifth and the negative 6p to the third. That's okay, that's one group. Now in the next group, that little trick I did before, I'm going to do again. Oops, sorry guys, my pen. I'm going to do again. I'm going to include the negative here and then write a little plus sign. Okay, now here's where things get a little bit tricky. Okay, when I find the GCF of this, that is normal. P cubed, I'm left with p squared minus 6. But this guy right here, they don't have a negative and a negative in common. They don't have a sign in common. However, because this negative is first, that guy right there, we need to pull that negative out because you can't have a factor that starts with a negative number. Like, for example, don't write this down, we don't have something like this, right? Like times x plus 4. Have we ever seen that with a negative in front? No, we don't do that. When we have something like that, we've made a mistake, right? So instead what we're going to do to kind of get around this little rule, I'm going to find the GCF of 2 and 12, but now I'm going to take the negative out of this. So I have negative 2 left, and what's inside, now that I've taken the negative out of p squared, it's a negative 2, but to make this a positive 12, I now have to turn that 12 negative. And you'll notice that if you want to check your answer, there are two things you can do. Distribute like before. Is negative 2 times p squared negative 2p squared? Yes. Is negative 2 times negative 12 positive 12? Yes. The other thing that will automatically check to see if you're right, because if you know, oh, sorry, not 12, guys. That should be a 6. Sorry, my bad. Sorry, 6. Okay, the other way you can really obviously check, and this is how I just saw that I made a mistake, is that this thing has to be the same as this thing. If they are not the same, something went horribly wrong. Like I just noticed that that was a 12 and that was a 6, so in my mind I'm like, wait, I did something wrong. Okay? So that's really one clear way in grouping you can do that. So now write your two binomials, p squared minus 6 times p to the third minus 2. And that is your answer. Okay? I've got 4 problems next that I really want you to try on your own. They might take 5 to 10 minutes depending, and that's okay. This video is not terribly long, so you have time to do that. Please go ahead and try them on your own, see if you can do them. If you can't, come to me, we'll work it out. Alright? Go ahead and pause. Alright, here are your solutions for these 4 problems. The only one that I feel like is kind of weird that I didn't really prepare you for was the first one. And I think the weird part is factoring out that y. That's not a huge deal. They both had a y in common, so you need to factor it out. So I think that might have been the only real tricky part here was that y. Otherwise, I think the rest were kind of what we did in the video. I hope you got them right. And if you didn't, you know what to do. There's one more thing we have to do here, and this part is kind of odd. So we need to remember that difference of perfect squares learning target. This binomial, a binomial, it's a difference of perfect squares. So for example, something that might look like 36y squared minus 9. This is a difference of perfect squares, right? If I have 4y squared minus 1, also a difference of perfect squares. And if you don't see that when you look at these two things, you're going to make mistakes because you're not going to realize that that can be factored even further. So I'm going to show you what I mean by this. So let's take a look at this group, right? I take a look at it. First thing I check for is a GCF. 54, 9, 24, and 4 do not have a GCF. But it is 4 terms, so I think maybe I can do this by grouping. I'm going to group the 54r to the third and the 9r squared here. And then I'm going to group the negative 24r and the negative 4. I'm going to keep the signs in and put a plus here. Alright, now I'm going to go ahead and find the GCF of both of these binomials. So the GCF of 54r to the third and 9r squared is 9r squared. They both have a 9 in them. What's left over is 6r and then plus 1. You know, I know we struggle with this, but if you take out this whole thing, it's left with an invisible 1. This next one, they both have a negative, so I'm going to put a minus here. And now they both have a negative and they both also have a 4. So I'm going to pull out that 4, and I'm left with 6r minus 1 here. I'm pretty sure I've done this correctly because I have a 6r plus 1 and a 6r, that should be a plus. See how you know you make mistakes? Because they just don't match. This has to be a plus 1 because I took the minus out of it. Okay, cool. Now that I've done that, I'm going to rewrite the 6r plus 1 here. And I've got the negative 4 and the 9r squared, so that becomes my next binomial. Now, in the first part of this video, I would have said, cool, you're done, put a box around it. However, when I look at my answer, I am noticing that 9r squared minus 4 is a difference of perfect squares. Which means that I can turn my answer into something even more exciting. I can turn that 9r minus 4 into 3r minus 2 and 3r plus 2, and then bring down the 6r plus 1, and I will have 3 factors in this problem. I know this is weird, okay? But when I give the directions factor completely, this guy right here is only partially factored, but this guy right here is fully factored. Okay? Both of these things will bring you back to the beginning. Mathematically, they're both equivalent, but this one is better. All right? I'm going to do one more example of this, and then you're going to try the last one on your own. So I'm going to go ahead and group 81n to the third and 63n squared. They both have that 9 in common, so 9n squared. And what's left over is 9n plus 7. I'm going to group this guy together and put my plus. They both have a minus in them, but nothing else in common. Now this happens sometimes, where, okay, they've got nothing in common, but really, if you were to put that 9 and 7 in your calculator, in fact, let me show you this, because you guys have done this before, where you've been to your calculator, we go to math, we go over to number, we go down to GCD, we hit enter, and if I put 9, 7, the calculator is going to tell me 1. That 1 means they don't have anything in common except for a 1. So what I can do here, and this is kind of sneaky, is I can take that negative and that 1 out. And I'm really left now with 9n plus 7 as my other factor. This is kind of sneaky and tricky. Okay? When I write my final answer, you know, it works here because, when I write my next answer, it's going to work because both of those are the same. So I've got 9n plus 7 here. And then what's left over is 9n squared minus 1. Now, when I look at this answer, I notice that this guy is a difference of perfect squares as well. 1 is a perfect square. So again, I can do this. I can say 3n minus 1 and 3n plus 1, and then bring in that 9n plus 7. Now this isn't going to happen crazy often. I'm not going to put like 10 of these questions on the test, but I might put 1 or 2 on them, and definitely on the mastery. So that's what I meant last learning target when I said you have to recognize this stuff. This stuff I have highlighted, you need to look at it and know, oh hey, it's that thing. I can do this thing. Okay? No one's going to just tell you that it's there. It's important you recognize these patterns. Okay? So with that said, I want you to go ahead and do the next problem on your own, and then unpause, show the answer, and we'll be done for this unit. Here's your solution correctly. If you made a mistake, please come talk to me. Otherwise, good luck on your practice.